Yes, class. Am I audible to all of you?
Yes, ma'am.
All right. So who all have joined? Austin, Faiza, Rabia, Shahid, Shavez, and Pari. All right. Now, look class, as we have discussed that potential part is over, what all topics we have discussed till now in this lesson. See, calculus we did, right? So again class, I'll take one more class of calculus on Saturday. So I hope all of you will be having your holiday. So all those, this is not compulsory for all of you, those who want. Like I remember Faiza, you were having certain difficulties in calculation of calculus that day. Tarif, you were having. So you people can attend that class. That will be just basic class of calculus, differentiation and integration. I'll let you know the timings. All right. So on Saturday morning, you can join 1.5 hour class. It will be on differentiation and integration. So that portion you can join and get your basics clear. All right. Those who think that they'll be able to manage with the calculus part, differentiation, integration both, then you can skip that class because that is not compulsory for all of you. But those who are having difficulties in calculus, differentiation, integration, you people can join the class on Saturday, and it would be just the basics of calculus, not advanced calculation, nothing else, whatever is required by you. The way we have been using, the way you can see integration was continuously used in this lesson. All right. Then we had seen the concept of electric potential. Electric potential was exactly everything similar to electric field, property of a single charge, but this was the scalar form, right? Then we had seen potential of dipole also. Due to dipole potential we had seen in both the cases, axial and equatorial line. Then the properties of equipotential surfaces were important, and then the electric potential energy, which we had seen, K Q1 Q2 divided by R. So this part we have already completed. Any doubts in this part, let me know. Text me right now also if you want. Otherwise also you can let me know so that we can clear your doubts. Now, starting with capacitance. So capacitance basically means, see, ability to store charges. Ability to store charges. This is mainly what is meant by when we say capacitance. And the device that stores the charges, that device is known as a capacitor. So how can you create a capacitor? Capacitor means, no, just take two conductors and have insulating material between them. Your capacitor will be created. Now see, ability to store charges or electric potential energy. Even if a device stores electric potential energy you have studied. So if a device stores the electric potential energy, then we call that phenomena as capacitance, that storage of charges. You will see how charges are stored, how charges are then further discharged for conduction to occur. That everything you will see by yourself. And the device specifically which we use for that purpose, that is known as a capacitor. Now, one basic formula of capacitance is required, which will lead to the creation of other formulas that you all can derive by yourself also. But just remember, if you remember this basic formula, which is written also on the screen, ratio of charge and potential. What is meant by ratio of charge and potential? We denote capacitance with the letter C. This is standing for capacitance. Ratio of charge. So Q is charge, potential is Q is the charge. And V is the potential. So ratio of charge and potential, this is known as capacitance. So C is equal to Q by V, or Q is equal to CV, V is equal to Q by C. All these three formula will be used throughout in this lesson, wherever you are using capacitance, because somewhere you have to derive the new formulas. So in that cases, you will be requiring this formula. Now, can anyone tell me SI unit? What is the SI unit of charge?
Coulomb.
Coulomb. Good. This is SI unit of charge is coulomb. Right, Faiza. And what is the SI unit of potential? SI
Voltage.
Volt. Good. It is volt. Yes, Shahid. Good. So this basically becomes 1 coulomb by 1 volt. But we don't use, you'll never hear 1 coulomb per 1 volt, right? We use this and call this unit as 1 farad. You must have heard of the scientist, no, Faraday. So based on this, we have the unit farad. So this is represented by this capital letter F. So 1 farad we'll use. So 5 farad, you will be seeing these kinds of examples. You will see 5 microfarad of capacitance, 3 millifarad, 2 farad, 5 microfarad, such capacitance you will see by yourself. All right. So this is what is meant by the SI unit of it. All right. SI, this is the SI unit of capacitance, which is farad. Capacitance of conducting sphere, I'll start, but just note down this basic introduction part, then I'll start with that sphere one. That sphere part is very easy. Initial portions are easy. You will be able to understand. Today, we'll try to focus on parallel plate capacitors. All right.
Yes, ma'am.
Written class till here.
Yes, ma'am.
I think all of you have written it till here. Now, see, regarding capacitance. See, capacitance of a conducting sphere. Conducting sphere means what? What is meant by conductor? See, when I use the term conductor, that means which allows charges to be on itself. Remember, I think we had done also conducting spheres, non-conducting spheres. We have seen this when we were discussing Gauss theorem's application. So same way it goes here as well. Conducting sphere means the charges are residing on the surface of the spheres. All right. So if I have a sphere or a point charge, everything for point charge and sphere remains the same. You can use same thing. So my question to you is, what will be the potential? If the charge on this sphere is Q given to you, radius is R, what will be the potential? Potential we have studied already. Charge is Q, radius of the sphere is R. So what should be the potential? Good, Austin. Anyone else? Shahid. Very good, Shahid. KQ by R. Good. See, for a point charge or for a sphere, we use this formula. All right. Even if you have a sphere or you have a point charge, you'll use the same formula, KQ by R. Fine. Now, class, I'll expand K. What was the meaning of this K, which the constant that we used to write? It had a value, no, 9 into 10 to the power 9. But what else? How can I write this K? Tarif, can you answer? K is equal to, I used to write something.
1 by 4 epsilon 0.
Perfect. 1 over 4 by epsilon. So I'll prefer to write it in this way. Why? You will see, because it's a very, very small derivation, but this derivation comes a lot. So, and it's very easy to remember. See, potential is this 4 pi epsilon naught R. This is the potential that I have. Just now we have studied the formula of capacitance. What was the formula of capacitance? Just now, I think you all have written in your notes. Just see what was the formula of capacitance. Q by V. Very good, Faiz. It was Q by V. So C is equal to Q by V. Humam, you have joined late.
Yes, ma'am.
Humam, please try to be on time. I usually start the class 5 minutes afterwards only. What is the actual time? Because you usually miss the starting portions of the class. All right. We are currently discussing capacitance and this is the formula. So I think even if you remember the formula, that will be enough. What is meant by capacitance is basically the ability to store charges. And the device that stores the charge, we call it as capacitor. That is what we are studying. And this is the main formula. C is equal to Q by V. You should remember this. That will be here. All right, class. So what we can do, class, we can put in the values of potential in here, right? We have got the value of potential. So see, this becomes Q divided by this entire term. This is our potential, which is Q by 4 pi epsilon naught R. So this gets cancelled. Now, at least we can write this entire term upwards. That goes in the numerator. That becomes 4 pi epsilon naught R. This is capacitance. Fine. So if you have capacitance of a conducting sphere, you can use Q by V. But why to use Q by V when you already know what is the value of V? Directly you will use 4 pi epsilon naught R. But class, one thing, if I am using the term epsilon naught, this has been used. Remember in the first lesson we have discussed this in detail. If this is the case, epsilon naught is being used. Can anyone tell me which medium this should be?
Vacuum.
Good, Shabis. Vacuum or air. Yes, Faiza. Correct. It would be air, right? So if your medium is air, this means this is the formula you are going to use. But does a medium always remain air? No, it can change. So one formula we had seen in the first lesson, and I have told you that will be used everywhere, which is, if suppose you want to find epsilon for any medium, just multiply the dielectric constant K, this K constant, with the epsilon. So what will be now your formula? What now your formula will become? this C dash, I'm just writing it as C dash just to differentiate it from the capacitance in air and the capacitance in a new medium. So this is C prime, which is 4 pi. Now, instead of this term, epsilon naught, we write K epsilon, right? K epsilon naught R. This becomes the formula in the medium, in any medium. Now, depending upon the medium, you will be having different values of K. So can you connect? C in air, C in any medium is actually K times the capacitance in air. So sometimes, no, in your very short answer questions, 1 markers, MCQs you have, value of capacitance in air will be given to you. Dielectric medium's value will be given, and in any other medium it will be asked to you. So do not waste your time in performing every step what we have discussed. No, directly multiply both of the quantities. You will get the capacitance in the new medium. All right. So C prime is equal to 4 pi epsilon naught K epsilon naught times R. No, so it's better you write it as K times C here. And class, throughout capacitance, this is an important formula. Right now, it won't be very much affected to you in the initial portion, but when we'll go to the derivations of parallel plate capacitors, there you will see C prime is equal to Kc. This is actually of very use to. This is very useful. Sometimes questions are asked, if medium is changed, will capacitance increase or decrease? So you can see this is getting 8 times multiplied. It will increase. So such types of question you all can also manage by yourself by just looking at the form. All right. Now, this is one concept where if your earth is acting as a conducting sphere, this is a very common question that's why I have made it as a separate heading. This is clear till here. The formula in air till now is 4 pi epsilon naught R. Suppose the sphere of which we are mentioning, of which we are talking, is, let's say that sphere is air and that sphere is earth and medium is air. So 4 is a constant, pi is a constant, epsilon naught also is a constant. In the formula, C is equal to 4 pi epsilon naught R. Only this R is unknown. No, you change the value of R, your capacitance will change. Now see, radius of earth we already know. This is 6.4 into 10 to the power minus 6 meters, right? 6,400 kilometers we write, that is the radius of earth. Class, if you put in the data, C is equal to 4, value of pi 3.14, epsilon naught. What is the value of epsilon naught? Humamuddin, what is the value of epsilon naught? Absolute permittivity in air or free space. This has been used a lot. And this is the last portion of electrostatics. Any idea, Humam? Just tell me yes or no, then I'll help you. Or at least turn your pages. You must have written it somewhere, Humam. Okay, see, now please remember. Can anyone else answer this?
Say 8.85
Yes.
to 10 raised to minus 2.
Good, Tari. 8.8. Now, Humam, please remember, because this will be used a lot, this epsilon naught's value. All right, just remember this part, 8.85. Fine, this is the initial part, 8.85. And what is the power of 10 minus 12? Like this. And those who do not remember, I'm not just mentioning you, Humam, others also, those who do not remember, right now on the top of your notebook, just write this separately. Epsilon naught is equal to this much, this. So that those who are forgetting, at least they'll have in mind that you have, because this is an important value. The way we remember the value of pi, no, 3.14, this is as important as it. All right, multiply. Okay, so 4 pi epsilon naught R. What is the radius of Earth? 6.4 into 10 to the power minus. When you will solve this, you will get this data 711 into 10 to the power.
Radius is 6.4 into 10 raised to 6, right?
Yes, Chavez?
The radius is 6.4 into 10 raised to 6, right?
Yes, this is 10 to the power 6. It's kilometers. No, this is written in kilometers. this is 6.6400 kilometers is the radius of Earth. No, so I'll write it in meters. This will be positive. Then only, no, when you will solve 6 minus 12, then you'll be left with minus 6. Otherwise, our answer would be positive. Thank you, Shavit. See, this will be minus 6 will be left, and when other quantities you will solve, no need to cross check this because this is a standardized data and you have to remember this data as well. Instead of learning this part, this entire farad, just remember 711 microfarad. 700 microfarad. That's it. Because in your very short answers, this will come. And suppose in your 3 markers, if this portion comes, capacitance of conducting sphere, then from here, mention it till here. Then only you will get your sufficient 3 marks. All right, I have seen in some of your papers, some of you have a habit of just writing very to the point answers, 1 word, 2 word. See, that will be helpful in the MCQ portions. But in your long questions or your 3 markers, 5 markers, you will not get sufficient score. So for that, it is important for all of you to at least write everything in detail, and whatever you have the knowledge, no, write it. So that whatever mark in your marking scheme that is present when the examiner is checking your paper, every question is being divided and the marks is being divided on the basis of steps. Even if your last answer is correct, something you have not mentioned the formula, half marks will be deducted like this. So have a habit of mentioning everything when you are writing it in for your class 12 board. After class 12 boards, for your entrances, for your MCQs, you can practice it in any way which you want to, where the final answer should be correct. All right. So this is important to write. So 700 microfarad, 711 microfarad is what? This is the capacitance if our Earth would act as a sphere. All right, this is the capacitance if the Earth's
Ma'am, here
yes,
the medium is air.
here the medium is. That's why we have taken 8.85. Right. If suppose medium changes, then what type, in which medium is Earth kept? Right. Earth is in vacuum, so we'll use epsilon naught. But that depends. See, if hypothetically we are talking about, suppose let's take a medium oil, for example, if the entire Earth has been dipped in oil, so multiply it with K, whatever is your answer, 711 microfarad, multiplied with the dielectric constant of oil. But since we already know that Earth is present in vacuum, free space in the space, so that's why we take this epsilon. So this can be this is just a little extension to it. Otherwise, main formula is C is equal to 4 pi epsilon naught R. And I hope by now this formula you all must be remembering it, because many a time this has been repeated. Note it down. Then we'll see the types of capacitors, and then we'll start with one of the types of capacitors. One only you have to do in detail.
can just scroll. You can just scroll up there.
Class written till here. Only Faiza has done. Others have completed, must have completed till now.
Yes,
Yes,
ma'am.
ma'am, done.
All right. Okay, class. Now starting with the capacitors, which is the main topic. See how to construct a capacitor. The best way to construct a capacitor is to take any two conductors. Any two conductors, random shape. I'll take it of random shape right now. Any two conductors, just take it. All right. Charge one with positive. Make one of the conductors as positively charged and make the other as negatively charged. So two conductors of opposite charges. One more thing is left with an insulating material, insulating medium in between. So here you are having an insulating medium. Insulating medium. Insulating medium you can say, or even you can use the term dielectric medium. This is actually dielectric medium. So this is how you can construct capacitor. But see, standard capacitors which actually come, they are of definite sizes and shapes. So three of them I'll mention to you, out of which one you have to do in very much detail. See, if suppose I take these two capacitors as just plates, single plates like this, rectangular plates, then look, I'll obtain a parallel plate capacitor. It's like one is this, another is this. These plates have been taken, parallel plates, they are kept parallel and wire is joined. And this is also the symbol for parallel plate capacitor. Suppose I take two spheres and then I charge one as positive, another as negative, and I made an insulating material in between them. So in that case, if you have spheres which are kept, then that becomes spherical plate capacitors. Suppose you are taking two cylinders. Then that becomes cylindrical plate capacitor. Out of which you just have to remember. See, we'll be discussing spherical also because lesser chances are there, but it can come. Cylindrical, no need to do for your CBSE class 12th boards. Just do it for your entrances. Remember the formula for entrances, log and all gets involved there. Parallel plate capacitor, this is the most important. Here we'll see different cases of which will come. All right. Now, before starting with parallel plate capacitor, principle of capacitors. So see, if you look at the formula, C is equal to Q divided by V. Can you tell me the relation between capacitance and potential? See, capacitance and potential are inversely proportional to each other. This decreases. If this decreases, this increases, right? So see, what is the principle of capacitors? Capacitance of a conductor can be increased by bringing an uncharged earth conductor near it. Earthed conductor, earthing, remember when we were discussing methods of charging in electrostats first lesson? Remember there we had seen earthing process. I have told you in potential it will repeat itself. So see, it's like, suppose I have taken this is one positively charged sphere. Not sphere, sorry, parallel plate. So it is saying conductance of a conductor can be increased by means conductance of this can be increased by, the capacitance can be increased by bringing uncharged earth conductor. This, and see, one more thing I'll do, I'll put them on insulating stands. I'll put them on insulating stands. So what will happen? The charge will not flow right now, so that only the charge which I want to flow is this part. Here, this process is known as earthing, where your potential becomes equal to 0. All your potential becomes equal to 0. That is what is meant by earthing. So here what will happen? All the negative charges will go inside the earth. So this will become neutral. So initially, if the potential was V1 plus V2, means potential of this plus potential of this will now only become V1, potential due to this. Clear? Just see, potential due to V1 plus V2, both the potentials were there initially when both the plates were charged. Now I have uncharged one. So what will happen? Now the potential becomes V1 only. See, if potential decreases, potential is decreasing. So what happens to capacitance? This increases. So capacitance of a conductor can be increased by bringing uncharged earth conductor near it. Because if it is uncharged, potential will be less. Potential is less, capacitance more. So this is just the basic principle of it. This can be asked to you. No need to go into the details. You have to go into the details of parallel plate capacitor, that I'll start. But first, just note down this part. See, Shahid, since the negative one will have even small potential, right? You're seeing it will have even smaller potential. So even if it is having smaller potential, so more capacitance is generated. So that's why we are preferring the negative one. If you try to earn the positive one, no, so it can happen in when you are trying to earn the negative one, it can make it neutral. It can make it neutral, but it can also happen that the positive charges, they are also moving. See, both can be earned. That is not a question. You can earn positive one also, negative one also. Any of these. So when we are talking about principles of capacitor, this is not very specific that we are negative one only or positive. Both can be. It's just that in whichever, right now we don't know the magnitude. I was just taking a random example. So if in a particular example, you are sure about the fact that here by earthing this particular conductor, you will get more of capacitance and less of potential, that you can prefer. All right, whichever one which can give you more capacitance, because more capacitance is required by us. All right, Shai? this. So no need to go into the details. This not the portion that you have studied right now, principle of capacitors. That is only your Van de Graaff generator. But a little more in detail was there, and it is present in your NCERT also, but do not study about it. Nowhere this is asked now. Now look class, I'll start with parallel plate capacitors. See, in parallel plate capacitors, but just one thing before you start with this. See, in parallel plate capacitors, we'll be using potential, concept of electric field. So all of you should respond at least to the first part. All right, once you have understood the first part that we are studying, after that, second part, third part, because we have different cases, that will be clear. So after writing this, please be alert. I'll ask you questions, try to respond. All of you should respond.
Yeah.
Yes, Tarif, good. C is directly proportional to Q because it's inversely proportional to V. So if more charge is there, more capacitance will be there. More potential is there, less capacitance will be there.
And there is more potential that will be had for the charge to come to the.
Yes, Chavez, you're saying something?
Like if there is more potential, so we have to do more work for the charge and bring it there.
Your voice is coming very low. Is it coming low to me, or are you others also able to hear him?
No, ma'am.
Because see, Rabia's voice is very clear, which is coming. Shaviz, I think just type it. Type it in the chat box. Your voice is coming very, very low. See, Shaviz, if potential is more, it will be harder for the charge to bring in the conductor. More than this concept, no. If you go by this concept, see, when we are saying C directly proportional to Q, that is just mathematically. See, when we are just coming to this part, the formula is C is equal to Q by V, right? So when I'm talking about this and this is mathematically true also and physically also true. C is inversely proportional to it. But when I talk about capacitance and charge, that is just mathematically directly proportional to each other. Actually, it is not directly proportional. I think Tarif was also asking this thing only. See, here you are having charge, and in the formula of potential also you are having charge. So capacitance actually never relies on charge. Here also, when we had seen the concept of potential due to a sphere, there also you could see the fact in charge is there, and in potential charge is there. So actually in everywhere charge gets cancelled, and without charge potential doesn't exist. So it means charge has to be present here, right? Charge has to be present here, and charge is already there in the numerator. So if charge is present in both the cases, there isn't any charge left. There isn't any capacitance left proportional to charge. So if you're just seeing mathematically, then you can say definitely mathematically it is proportional as in by the formula. But actually physically, if you're saying this is not possible because numerator and denominator gets cancelled, but it is depending upon potential, because potential is not just a property of a single charge. It comes into groups, right? And it depends on many factors. So when we are talking about charge, more than what the reason you were getting, it's more of a mathematical thing when we are writing C is equal to Q by V. This is not actually proportional to it. It means if whatever amount of charges you are containing, directly if you're writing the formula, by formula you can go. But actually in reality, we relate physics in real life, then charge is not depending upon capacitance, because see, directly you can see both of the numerator and denominator gets cancelled. Now coming to this part, parallel plate capacitors. Everyone should be alert and all of you should be responsive. See, two plates I have taken, right? Two plates I have taken, parallel plates, and I have kept them parallel. Separation between both the plates is small d. Fine. Separation between the plates is d. Charge on the plates is q. A is the area. And sigma, already I have done this in detail as a separate topic with all of you. You should remember this, and this will be used. This will be used. Sigma, that is surface charge density. Sigma is surface charge density, means charge per unit area. So instead of depicting this, making all the rectangular plates, it's a little difficult. So I'll just use a single line to represent it. So this is one plate, positive charge. Charge is Q, area is A, plus sigma, that is surface charge density. And this is the second plate which is kept parallel to it, negatively charged, minus sigma surface charge density. Charge is Q, area is A only, and separation between the plates is still D. Fine. Now I have connected both the plates to a battery. Now see, electric field will move from the positive to negative. Electric fields will run like this from positive to negative. Can anyone tell me, due to this single plate, positive? Okay, again, one more thing. Why is the electric field just moving downwards? See, because of the positive charge, electric field moves away. So see, electric field is moving away from the positive. And electric field lines move towards the negative charge. So this will move towards the negative charge. That's why we are having them in the same direction. Whether it's going upwards, downwards, that is not important to you. What is important to you is whether they are in the same direction or they are in opposite direction. Why? Because then net electric field will be addition of it. Had they been in opposite direction, you would have subtracted it. Right now, both of them are in the same direction. Why plus E is in the downwards direction? Because this is moving away. And why negative is in the downward direction? Because it is moving towards the negative charge plate. Plus E because of this, minus E because of this. So Do you remember the formula? One formula we had seen under the application of Gauss theorem for infinitely plane sheet, electric field due to infinitely plane sheet. What was the formula? Chavez isn't audible. Chavez, you please type. Your voice is coming with. Please check your mic and volume also, Chavez. Others? Yes, Madiha, do you remember?
Ma'am, formula for electric field.
Electric field. Yes, electric field due to plane sheet. Were you there when we were discussing that?
No, but
Yeah,
I think I might.
but do you remember the formula in any ways? Okay, now you
2K lamb. Okay, no, that is for something else, I think.
that
2K
is
lamb.
for your
Yeah, for.
telling for the wire.
Yes,
Infinitely long wire.
ma'am, by 2 epsilon naught something, right? In the denominator, sigma by 2 epsilon naught.
Sigma by 2 epsilon. Very good. Chavez, which you are mentioning, no? That is for two plates. Both the plates you are mentioning. Sigma by epsilon naught. For electric field due to just single plate, rightly answered by Madiha, Shahid, and Faiza. That is, see, electric field due to this positive plate, just this positive plate will be sigma by 2 epsilon naught. Plus, electric field due to the negative plate will be sigma by 2 epsilon. And the way Chavez was answering, total will become sigma by epsilon. So electric field is sigma by epsilon. What was surface charge density? I have mentioned right now also. Surface charge density is charge per unit area. So sigma is Q by A, right? Sigma is Q by A. Now, class, one more formula we had seen. Lots of formulas usage will come. This derivation comes a lot. This is a very, very important derivation. So please be careful. That's why I want all of you to keep on responding in this. Remember one relation we had seen between electric field and potential. Faiza, can you answer this? Electric field and potential. Potential gradient was involved there. Relation between electric field and electric potential. Faiza, can you try? Rabia? Potential gradient was involved somewhere. Distance was also there. One formula we had seen. And I've told you that is very important. You people are forgetting the potential portion, no? See, I'll take a test on Friday. This part, not even the calculus, this won't come separately. Electric potential, potential due to dipole, equipotential surface, and electric potential energy. These four, all the topics that we have discussed in electric potential. Potential is your topic for the syllabus for your Friday's test. Capacitance I'll not ask. First chapter I'll not ask. The separate questions for calculus I'll not ask. But at least you should be thorough with these four topics. And all of you should appear for the test. In the last test, all of you didn't appear. Right? So some of you. Good, Chavez. Yes, Faiza. E is equal to minus dV over dr. This is the formula. Remember, we had seen minus dV over dr. This is very important. This formula particularly is important because this has been repeated in your previous year questions also, if you see. So E is equal to minus dV over dr. Last question from today's. Yes, ma'am. Just stay after the class. I'll show.
Okay, ma'am.
See, from here, directly, I can write it as the way you were mentioning very well. Someone was mentioning, no, Chavez. Chavez was mentioning electric field is potential divided by distance. So potential is actually electric field multiplied by distance. Class steps will remain the same. You will be seeing different cases. Please understand this first derivation. I'm taking a lot of time in this first derivation because the rest of the derivation are just exact step. Finding electric field, finding potential, putting in capacitance. That's it. So V is equal to ED. Now, what is electric field? electric field is sigma by epsilon naught. Can I write sigma is Q by A? See, electric field is sigma by epsilon naught, and sigma is charge per unit area. So I can write electric field as Q by A epsilon naught. This is electric field into distance. What was the formula of capacitance? Capacitance formula is C is equal to Q by V. Let's put in the value of V, which is Q, and above will go A epsilon naught, right? Into D. So D is here, right? Q, this one Q is here. One Q is this first Q, no, this the Q that I'm writing. This is the charge here. And potential's value is QD by A epsilon naught that I have written. So this gets cancelled. Formula for capacitance becomes A epsilon naught A by D. This is the formula for capacitance between parallel plates. But one condition is that air is the medium between them. Here air is the medium between them. So this is capacitance in air. Suppose medium gets changed. This is nothing different, nothing new we have studied. If medium is different, multiply K with the capacitance in air. What is the capacitance in air? This is the capacitance in air. If suppose medium between the plates is a dielectric constant, then we write it as K epsilon naught A by D. That's it. Means between the plate, the medium which is kept, this medium, this is your dielectric constant K. Now class, I am just summing it up. Please be careful. Please listen to it carefully. This is very easy actually. Just the steps are same. We'll see different cases. The steps will be same exactly. What do you do first? Bring the parallel plates, take the current electric field, whatever electric field is coming, whether it's getting added, subtracted. So find electric field. You use the formula V is equal to ED. In this formula, put in the value of electric field and D. Once you have the value of potential, you can put it, take the ratio of charge and potential and get the value of capacitance. This is just a step. Note this down, then we'll see two more cases. At least one, this one. If a dielectric slab is partially filled, this we'll see. So two cases you have seen. One case is this, when between the air, nothing is kept, just a dielectric medium, separation between the plates. And if suppose just air is kept between the plates. If suppose a dielectric medium is kept between the plates, then you multiply it with K. So two cases you have seen. Suppose in your exam class, a question comes, this question comes, completely derive the expression for capacitance of parallel plate capacitor with completely filled dielectric medium K. Then do this entire derivation, or what you can do, instead of this also, one more thing which you can show is directly you can keep on adding K everywhere. If you add K here, so automatically K will come here also. So that depends the way you want to write, but the basics of the derivation remain the same. I think it's better if you put K here if that derivation comes. Otherwise, usually this derivation comes, derive the expression for between parallel plate capacitors with air filled between the plates. Note this down, understand this, then we'll discuss one more case. At least I want to complete it today. Quickly note it down.
Done, ma'am.
No, air is not a dielectric medium. That's why we are writing air separately and dielectric medium separately. Other insulating materials are dielectric medium, but not air. Air, for air, we write it specifically. That's why. So remember the formula also of air separately. C class, parallel plate capacitor with dielectric slab in between. See, when this slab wasn't there, just air was there between them. Capacitance formula was epsilon naught A divided by D, right? When entire was dielectric slab only, then the formula became K epsilon naught A by D, correct? These two cases only we have seen right now, when full was dielectric and when one was complete air. Suppose if the dielectric slab not only but partially fits in like this, the plates are here but partially fits, means air is also present, dielectric slab is also present. Now what will happen? See, we break this into two parts. T is the thickness of this. Thickness of the dielectric slab is T, and D is as usual the separation between. Steps remain the same. See, electric field due to this air. For air, I'm writing not because we are familiar with this symbol. No, epsilon not also we write it for air. So electric field due to this plate, this will, due to both the plates, will be epsilon naught by sigma by epsilon naught. Right, in the previous example also we had seen, because of one plate you will have sigma by 2 epsilon naught, because of second plate also sigma by 2 epsilon naught. When you get added it is sigma by epsilon naught. That is still same here. But now I will mention the electric field due to dielectric slab separately. Because of it, it will become sigma by epsilon naught K times. Remember, this is how we write. So for both these plates, means the dielectric slab, this is the electric field. What is the net electric field? I have told you steps remain the same. This is the first step, finding electric field. What is the net electric field? Sigma by epsilon naught plus sigma by K epsilon naught. Coming to potential, potential's formula, potential difference between the plates, V is equal to ED, we write. But is it still ED? Is it just ED? We have two types of plate now. Two types of plates are present. So see, electric field due to the dielectric slab multiplied by the distance, V is equal to ED is the formula class. Electric field due to dielectric slab multiplied by, will we still write this entire separation as the distance? No. Dielectric slab's thickness we will write. Electric field due to dielectric slab is associated till the thickness only. So electric field of dielectric slab multiplied by its thickness, right? Because that is the distance. Potential is electric field into the distance. Fine. Now see, this is in multiplied by T. This was still easy here. When I'm talking about electric field due to air, can anyone tell me what is the thickness or what is the distance that I should take? Anyone from the class? Austin, can you try? Good, good. Austin has already answered. D minus T. Very good. See, when I'm talking about just the portion that is left within air, no. Thickness slab is deleted. So how much is left for air? D minus T. This distance and this distance is actually D minus T. Very good, Shai. This is D minus T. So the distance is D minus T. This is what was required by us. Now see, and again, sigma is equal to Q by A only we'll use, because we know without Q getting into our derivation, final answer won't come because capacitance already involves charge. So electric field due to dielectric slab. This is Q by A sigma by K epsilon naught. So sigma Q by A K epsilon naught multiplied by thickness plus. This is just sigma Q by A sigma divided by epsilon naught, right? D minus T. This is the formula. One thing we can take common, because this is becoming very huge, at least we can take Q by A epsilon naught as common. What is left? T divided by K, and from here plus D minus T is left. Now, what was the last step? We have obtained the potential. What is capacitance? What will be capacitance? Charge by potential. Charge divided by, what is the value of potential? Look here. Q, this entire term. T by K plus D minus T. This entire term here. And A into epsilon naught will go up. Right? Anything gets divided. It's like this entire term is kept here in the denominator. Q gets cancelled. What is the formula that has been obtained? This is A epsilon naught divided by D minus T plus T by. So this is the formula you will use. Derivation can come. Now you can see derivation is not difficult. Just understanding small steps is important. All right, so A epsilon naught D minus T plus T by. Quickly note this down. This part, Shaviz, this you want to write? Others have also completed. All right, class. One more case is left, but since time is not there, I'll not do start with that. But please revise it till here. On Saturday, all those who require the classes, please take the classes of calculus. I think Faiza, Humam, Tarif, because you were having difficulty. Faiza, you were also asking me something from that. And Madiha, I don't know, Madi, I think you have missed the classes or have taken the classes for that. All the new students also who have missed the classes for calculus, because see, that will be used everywhere till your last lesson. So those who want to join, you can. Those who don't want to, this is not compulsory. Directly in the next class, we'll continue. All right, class. Thank you so much. Please wait for your class assessment. And everybody should give. Tarif, you have just given it on 17th and 15th. Please appear for these diagnostic tests. These marks will not be added anywhere. Wherever you are having difficulty, whichever question, separately mention it. I'll discuss it. Just mention the question which you are having difficulty. At least the basics 1, 2, 3 questions should be cleared by all of you. The advanced, it can happen that you are not able to answer, but all the basic questions, wherever you are having difficulty, let me know. If you want, for your basics also, different classes can be arranged. Separate classes will be arranged if you're having difficulty for that. And regarding the backup for first lesson, who all have missed the first lesson? Is there anyone who has missed the entire first lesson? No one, all of you have joined. All right then, if any difficulties is there, please let me know. All right, class, please wait. Thank you so much. Madiha, also, you were saying you wanted to see some question. Please let me know. OneNote link of this chapter I'll send Tarif, but at the end when I'll complete this lesson, then I'll send you. But if you want to write some portion that has been missed, let me know. Madiha, something you had asked me, no? This question?
Yes, ma'am. Yes, ma'am. Like the questions from the last class. Yes, yes, yes.
Okay, please note it.
Yeah, ma'am. Ma'am, I'll take the screenshots. Can you scroll down?
Yes, yes, please do it. Done?
Yes, ma'am.
Okay, Maria. Thank you so much.
Thank you, ma'am.
Class, since some of the time has already been used, so I think diagnostic test we'll be able to do. What we can do, we can just take 5 more minutes and complete the last case that was left. Right, the last case that was left, we can complete that. It will just take 5 more minutes of yours. See, this I wanted to discuss with a conductor in between. See, if a dielectric slab is kept between with a conductor placed in between. This is just the last case we'll discuss, and before even the time you will be free, because test will not be held today. So see here, if a conductor is placed, no, this is a very easy, a very short case. See, electric field due to the plates, it will still be sigma by epsilon naught. But electric field due to conductor, remember I have told you inside conductor there isn't any charge. Charge resides on the surface. So electric field inside the conductor will be 0. Fine. So when we write the potential due to the plate will be d minus t still, plus potential due to, that is electric field multiplied by electric field due to conductor multiplied by the thickness. This term becomes 0. You directly get q by a epsilon naught d minus t as the potential, because electric field is sigma by epsilon naught and electric field becomes q by a epsilon. Right, sigma, you put the value of sigma as q by a. So when you write the value of capacitance, this becomes q divided by q d minus t a epsilon naught. So q gets cancelled. Formula of capacitance becomes epsilon naught a d minus t. That's it. Now I'll just sum it up, just a quick short summary, and please revise these 4 formulas, please class, because this is the most important portion for you. This is just a summary. When you had the capacitor and completely it was filled with air, formula was epsilon naught a by d. When between the plate completely dielectric medium was kept, so the formula became k epsilon naught a by d. And when between the plate a partially thickened slab with dielectric medium k was kept, then the formula was epsilon naught a divided by d minus t plus t by k. And when between the plates a conductor was kept, formula was epsilon naught a divided by d minus t. Formulas you should remember for the numericals, and each part you should remember for the derivation purpose. So quickly note this down. Just make the heading, and that will complete off with the parallel plate capacitors capacitance. The rest of the topics I'll do it in the next class. And please write that summary part also. So at least we have the formulas all together. All those who have completed, you can start leaving. Class is over.